Welcome back, students, to Chemistry, Unit 7, Stoichiometry. Today we will be talking about Unit 7.4, Limiting Reagents and Percent Yield. Every week when I go to the grocery store, I go to Costco and I buy my bread. My bread in Costco comes in a pair of loaves, so I get 2 loaves of bread when I go grocery shopping. I also buy a pound of cheddar jack cheese. So with my weekly grocery shopping, what is the maximum amount of grilled cheese sandwiches I could make? This requires you to do a little bit of thinking. 1 pound of cheese is 16 slices. And each loaf of bread provides me with 20 slices, so I have 40 slices of bread. So with 40 slices of bread and 16 slices of cheese, what's the most number of grilled cheeses I could make? This is known as a limiting reagent problem because one of our reagents is going to limit the amount of product, grilled cheese, that we can make. When you do a limiting reagent problem, you kind of have to look at each one individually. With 40 pieces of bread, in the ratio of bread to grilled cheese, I could make 20 grilled cheeses. With 16 slices of cheese and the ratio of cheese to grilled cheese, I could make 16 grilled cheeses. So how many grilled cheeses could I make? I could only actually make 16 grilled cheeses. My cheese is limiting the amount of grilled cheese I could make. So we would say cheese is our limiting reagent. It limits the amount of product we could make. So we would make 16 grilled cheeses. The other reactant, in this case the bread, is our excess reagent. We're going to have way more of it than we need. That, in a nutshell, is what this little subunit is about. In a real chemistry problem, you'll be given all your reactants, and you need to figure out which one is going to limit the amount of product you can produce, because that limited amount is the amount you can actually make. The excess reagent, the one that you have extra of, is just going to be left behind. So again, a limiting reagent is the reactant that limits the amount of product you can produce. Whatever is left over is known as the excess reagent. All stoichiometric calculations must be done based off of the limiting reagent. I can only feed 16 people because my limiting reagent, the cheese, limited the amount of product I could make. While I could, in theory, produce 20 grilled cheeses, that's not the situation that happens. I'm only going to be able to make 16 grilled cheeses. So we base all stoichiometric calculations off of the limiting reagent. So let's find one of these in your packet. In example 7, we have tetraphosphorus decaoxide reacts with water to produce phosphoric acid. If I have 0.4 moles of tetraphosphorus decaoxide and 1.5 moles of water, I need to figure out what the limiting reagent is, calculate the number of moles of product form, and then figure out how much of the excess is left over. So this problem has 3 steps. In order to determine the limiting reagent, you have to figure out how much product you can form. So we're going to go a little out of order. We're going to start with number 2, figuring out the amount of product formed. When you have a limiting reagent problem, when you receive 2 amounts of reactants, you have to figure out which one is your limiting reagent, which means that you have to do the problem twice. With 0.48 moles of tetraphosphorus decaoxide, I need to figure out how much product I could form. In this case, my product is phosphoric acid. I use the balanced reactions coefficients to convert from tetraphosphorus decaoxide to phosphoric acid. That will cancel out tetraphosphorus decaoxide and give me phosphoric acid. Based off the amount of tetraphosphorus decaoxide I have, I could make almost 2 moles of phosphoric acid. But that's not our answer. We have to figure out how much the water could make. With 1.5 moles of water, we need to figure out how much phosphoric acid that is. So again, we'll use the balanced chemical equation, since we're in moles, to convert from water to tetraphosphorus decaoxide, which will make 1.01 moles of phosphoric acid. Since 1 is less than 2, the lower amount is the amount you make. So the answer here is 1.01 moles of tetraphosphorus decaoxide, meaning that water is our limiting reactant. So we have to do all stoichiometric calculations based off of the water. Tetraphosphorus decaoxide is our excess reagent. P4O10 is what's going to be left over. How much is left over, we'll have to calculate. We started with 0.48 moles of P4O10. The amount we started with, stated in the problem. We need to figure out how much was used based off of our limiting reagent. So with 1.5 moles of water, we need to figure out how much tetraphosphorus decaoxide was used up. So again, we'll use the balanced chemical equations coefficients. For every 6 waters, we needed 1 tetraphosphorus decaoxide, telling us that we used up 1/4 of a mole. So if we used up 1/4, how much is left over? 0.23 moles of tetraphosphorus decaoxide is in excess. Meaning when the reaction's done, this is just going to be floating around in our beaker or our reaction chamber. Why don't you pause the video and try example number 8. If you have 6 moles of hydrogen and 3 moles of oxygen, how much water could you form? Which one, hydrogen or oxygen, is your limiting reactant? And then how much of the excess remains? Pause the video and see if you can find out. With 6.4 moles of hydrogen, we could make 6.4 moles of water, since they are a 1-to-1 ratio. With 3.4 moles of oxygen, we could make 6.8 moles of water, since they are a 2-to-1 ratio, making hydrogen our limiting reagent. We can only make 6.4 moles of water, so our excess reagent, the oxygen, we could calculate by taking the amount we started with, 3.4, and subtracting the amount that we used up. Based off of 6.4 moles of hydrogen, hydrogen to oxygen is a 1-to-2 ratio, so we would use up 3.2 moles of oxygen. So 0.2 moles of oxygen are in excess. Limiting reactant problems are exceedingly rare on the SOL. However, I will give you at least 2 on your test for this class. So you do need to be able to do limiting reactant problems. So for your note quiz questions, number 1 and number 2 are similar to the one you will see on your tests. So if you can do number 1 and number 2, you will be fine for your multiple choice portion of your test. The free response, however, will ask you to do a gram to gram calculation. It's the exact same. Start by figuring out how many moles of iron and how many moles of oxygen you have, and then you'll be able to determine what the limiting reactant is and then convert that answer back into grams. Pause the video and complete note quiz questions 1 through 3. Lastly, if we carried out this experiment, if we took hydrogen gas and lit it on fire, it would make a barking noise and produce water. If we started with these values, no one, including myself in the course, would actually be able to make 6.4 moles of water. We would all make different values, and that's because chemistry and all sciences are messy. In theory, we should have been able to make 3.4 moles of water. That is the maximum amount we could make given the reactants we had. However, when we conduct an experiment, we most likely would come up with very different numbers. If your group is extremely good, you might be able to make 3.2 moles, or you might be able to make 3.5 moles. But some people will make something crazy like 6 moles, when some people will make only 1 or 2 moles. Experimental yields never or exceedingly rarely match your theoretical yields because experiments are messy. When you transfer one substance from one beaker to another, some can get left behind. So there might be some residue during any of your transfers. In the lab that goes with this unit, you'll be asked to decant a solution off of the top of your beaker. Decanting means you pour out slowly, and it's very possible that as you pour out, some of the solid that you're trying to capture might go out with it. So you might have lost some product. If we're working with gases, we said 1 mole of any gas occupies 22.4 liters, but there's an asterisk there. That only occurs if you are at standard temperature and pressure. Meaning if you are not in the middle of a snowstorm next to the ocean, this value does not hold true. At higher temperatures, where you most likely conducted the experiment, is probably 20 degrees Celsius. Where you conducted an experiment at 20 degrees Celsius, gases will occupy more space because as you heat those molecules up, they'll move further apart. Also, this lab, my classroom, is on the 2nd floor. We are at a higher elevation, so our pressure is less. Our gases will occupy more space. In this room, most likely the volume of 1 mole of a gas is something a little bit more, like 24 liters or 23 liters. And because of that, we might not be at the perfect conditions. So percent yield is a way for you to analyze your data. How close to the perfect value, your theoretical yield, were you? How close to getting 100% of the product were you? So percent yield is when we take the experimental value, what you got in your experiment, and divide by what your math, your stoichiometry says you were supposed to get, times 100. So if you performed a reaction between silver chloride, which is this clear solution here, and you put solid copper in it, a penny or a wire, the solution will turn blue as the copper and silver undergo a single replacement reaction, producing copper ions. That's why the solution turns blue, and the wire or the penny you put in will turn silver as silver deposits on it. So if you conducted this experiment with 0.9 grams of copper and then produced 3 grams of silver, what's your percent yield? Copper is the reactant. You put that into the reaction, and over time it produced the product silver. So silver, this 3 grams of silver, is your product, meaning that this is what you produced in the experiment. This is our experimental yield. To find our percent yield, we take our experimental yield divided by our theoretical yield times 100. 3 grams of silver is our experimental yield. It's what we got out of the experiment. It's the product. So we have our numerator for this calculation. We need a denominator. We need to know what our theoretical yield is in order to solve this problem. So to find our theoretical yield, we have to take our starting amount of our reactant, 0.9 grams of copper, and convert that into grams of silver. So we'll need to change from grams to moles. All stoichiometric calculations require you to be in moles. So the first thing is we've got to cancel out grams and go to moles. We use the molar mass of substances to do that. So grabbing a periodic table, you look up the molar mass of copper, which is 63.55 grams for each mole. We now have moles of copper. We can convert, once we're in moles, we can convert from one substance in a balanced reaction to another using the coefficients. So for every 1 copper, there were 2 silvers produced. This will cancel out copper, giving us moles of silver. We need to be in grams in order to use the 3 grams of silver that the experiment pushed out. So we must convert from moles back into grams using the molar mass of silver. So again, we grab our periodic table. Silver's molar mass is 107.99 grams for each mole, canceling out moles and giving us grams of silver. So we produce 3.16 grams of silver in theory. This is our theoretical yield. Again, percent yield is when we take our experimental yield, 2.98 grams, and divide by our theoretical yield, which we just calculated as 3.16 grams. And it's a percentage, so times 100. Doing that tells us that this experiment was 94.2%. Produced 94.2% of what we should have, which is fairly good. Most likely, when they conducted this experiment, when they poured this blue solution out, they lost some of the silver, but they only lost about 5.8%, which is not terrible. If another student conducted the experiment and was able to capture 3.4 grams, what is their percent yield? Percent yield is your experimental yield, which their experiment made 3.4 grams, divided by your theoretical yield. Since this student started with the same amount, their theoretical yield is the same. Was 107.6% yield, meaning they collected more than they thought they should have. When you conduct this experiment in lab, we will have to isolate the silver. We'll put it onto a watch plate or onto a piece of filter paper, and we'll allow it to dry. The student who had over 100%, their sample must not have dried all the way. There must still be some water present. So with that being said, here is your final 2 note quiz questions. You're also able to do page 24 and 25 in your packet. And that brings us to the end of Unit 7. If you are in class, we will do the either the silver nitrate lab, where we isolate silver, collecting it onto the surface of a penny, or we will do the iron filings lab. It depends on how the school budget is that year. Silver nitrate's really expensive. This test is unique in the fact that this test is not 25 multiple choice questions. Since stoichiometry requires a decent amount of work, I will be giving you only 20 multiple choice questions. Again, I'll still hold you to the 85%, so you have to get 17 of that 20 right to earn 100. Your free response will have 10 possible points. You need to earn 6 of them to get 100, just like you did on your quiz. Make sure you do your multiple choice homework. If you do it early, I can check it and tell you which ones you missed, and you can do it again. When you sit for the test, your homework is due. I will see you guys in Unit 8 for thermochemistry and gas laws. Good luck.